If you're fed up of picking your own bits of wire off the floor, you can get yourself an employee. My 2-year-old has seems to like my workshop.
Can you put it in the bin?
Yeah, I'll put it in the bin in a minute, sweetheart. She doesn't like my workshop to be untidy. You say who's on there?
Daddy and me.
Yeah.
You're working while I'm sweeping up.
Yeah, I'm
Can I
working.
have the brush?
Yeah?
You sweep all the mess up over there and put it all in the bin.
Okay, you're going to say hello to YouTube? Say hello, YouTube.
I've got the brush.
Yeah.
You have this and I'll sweep it all in the pile.
Say hello, YouTube. Say hello, YouTube. You're not going to talk now, I'm shy.
You come over here and I'll sweep.
Forgive the mess of wiring that you're looking at the moment. Unfortunately, this is what they look like when they're a work in progress. Obviously, it'll all be tidied up at the end. I've now got my Arduino installed for Air Manager, and I've got all the LEDs hooked up with their resistors in line, which you can see are under the black heat shrink. I've interfaced it all up, checked it all, and it's working. So every LED on the front here, so the ones behind the buttons, and of course the auto throttle and the master arm flight director lights each side are all working. So that's a weight off my mind. I know that that's sorted. So now it's back on to wiring the displays. These will be connected with SimVim, and finishing up wiring the wires along the top of these breakout boards for the buttons. And what I've done is made myself a little SimVim station, if you like. This is just mounted on a bit of I actually bought this red perspex for the fire warning light, but in the picture it looked like it was see-through, but when it turned up it's solid red, so no light can shine through it. So I can't see me making use of it anywhere else, so I thought that would be the ideal platform to then mount this is the SimVim Arduino. Same setup, just the Arduino underneath with the breakout board on top, just to convert it to screw fitting. And then I've made this little breakout board here from like a prototype strip board. So each of these holes running this way are all linked. And then I've just soldered on a load of pins, which I will solder directly to when it comes to hooking up the MCP. These wires here are from pins 22, 23, 24 and 25, which are the signal lines for anything used by SimVim. So what I've done is run a wire from pin 22 on the Arduino and connected it to the first strip. So all these pins effectively are now pin 22. So it gives me lots of options to break it out into different directions around the cockpit. Same with the next one, a row of pin 23, a row of pin 24 and a row of pin 25. Then I've got a row of pin 26, which is used for the 7-segment displays. I've then got a row of grounds. Then I've got a 5-volt output and a 6-volt output. The reason I've got 6 volts is because the white displays that I'm using don't like 5 volts for some reason. I spent almost a day messing about with them. They seemed to work fine, but as soon as you turned the dial, the display just went random and showed a load of gobbledygook. No matter what I changed in the settings, I could not figure it out. And then I thought I'll just try 6 volts and see what happens. And as soon as I put 6 volts on it, everything worked fine. So that's the reason why I'm running a 6 volt output. That will just be for the white 7 segment displays. So that's where I am currently. So okay, this is going to appear a bit out of order, but my MCP is now finished, and I was watching back through, I mean, I've made about 25-ish separate videos that I've got to edit down into probably a couple of parts for YouTube. And while I was watching through the video where I was talking about this board I made for SimVim, I talked about what I've wired all these pins for, and later on you'll realise that the 6 volts is not actually needed. It was actually an issue with the output ampage of my power supply. 5 volts with a higher ampage output was fine, so these are not required. And also I noticed in the video that I hadn't at the time mounted this terminal strip, which is actually connected to pin 27 and 28 on the Arduino. And 27 and 28, they have to run to every Max 7219 driver board that you have. So every Max 7219 has to connect to pin 27 and 28. 27 is the CS. If I just grab this driver here, you can see these pins, you can completely disregard them for SimVim, because what they're for is they're for daisy chaining more of these drivers together, and SimVim doesn't support that, so there's no need to even look at them. These are the ones that we need. If I can get the camera to focus. So the pin 27 always runs to the CS pin, and pin 28 always runs to the DIN connection. So that's the reason why I've added this, and you can see that I've only got 2 wires running my whole MCP for pin 27 and 28, because all I've done is this green one and this yellow one are connected to the DIN and the CS, and then I've jumped from this board to the next board with those pins. So basically 27 and 28, jump all 3 boards. That's absolutely fine. So while we're looking at this, you can see that my whole MCP is wired to this breakout board. These purple wires are my 4 signals for my signal pins that run to the Arduino, so 1 for each multiplexer. I'm running 4 multiplexers in total, and each of these wires controls 16 buttons or displays. So I've got 3 multiplexer inputs for my buttons, and I've got 1 multiplexer output for my display. And you can see over here I've got 1 wire going to 22, 1 to 23, 1 to 24, 1 to 25 and 1 to 26. I've got 1 wire going to ground, and I've got 1 wire going to plus 5 volts, and this carries up to where it plugs into my MCP via this plug, and then from there on it's then distributed throughout the boards. This is my first Max driver, so this is where I brought the pin 27 and 28 into, and then I jumped from there across to this one, from there across to the last one over here. So sorry for the out of place edit, but I thought it was I thought I'd already talked about this. It was only when I was watching my videos back that I realised that I hadn't, so there you go. Now it's back to the MCP, and the first job I need to do is figure out some sort of small distribution board that I can put on the back here, so that I can run only 5 or 6 wires from my Arduino breakout board to this distribution board, which will then distribute all the lines in different directions to where they need to go. The fun never stops, does it? Well, this is it. Hours and hours and hours of soldering, and this is the last wire. All my switches are wired, all my LEDs are wired, and with the addition of this wire, all my displays will be wired. I'm not going to lie, it's been quite a marathon of soldering over the last, I suppose, week. Just doing like 4 or 5 hours in the evenings. It's been some late nights, there's been some early mornings, but what I'll do is I'll just solder this on. I'll have a tidy up, and then I shall show you what it all looks like. I'm not gonna lie, there's been some tears. I've actually, while I'm here, I've actually changed. Originally I was desoldering these black pins on the Max boards. I did find though that I was having a few issues. It's probably me and my soldering skills, but I was finding that once they were all soldered up and I tested it, I was getting some segments that weren't lighting, some that were dimmer than others. They'd randomly go off. I thought I had a dodgy board, so I desoldered all these cables off of one board, soldered them onto another, and then I got different segments that were dim and missing, and it was just an absolute headache. I was fiddling around, resoldering them, testing it, resoldering them, testing it, and in the end I just said, right, I've got to do this different. So what I've done is I left these pins, I pulled the old displays off, and left the pins behind, and then what I did was poked my wire down inside the hole and then just soldered around the top of the wire, and I've managed to do this and this in the same time it took to do just those two. So it was definitely a better way for me personally of doing it, and touch wood, since I've started using the pins, I've not had one single problem. I've tested up to here, so the last one I've got to test is just the captain's course, and then I know that every single display is then working. So next job I've got to do is to put a little board on the back to distribute my power to each of the max boards, and I've got to bring my wires in for the multiplexer boards, and I've also got to add one more multiplexer to run the displays. So not quite done with soldering yet, but very close on the home run now. Well, here it is everybody, the finished MCP. I thought what I'd do is just show it now that I've tidied up all the wiring, and just explain what I've done with connecting it to SimVim. So I'll start with the first officer side, is where I've fitted this little plug so I can unplug the MCP should I need to, and obviously this wire loop then runs to my red board here, which you saw earlier. It was my SimVim breakout board. What I should have done was added these 4 cables into this loop, but I got carried away and forgot, so I had to run them separate. So these 4 purple cables are the input pins coming from the Arduino, which in my case is pin 2, 3, 4 and 5. That's the only 4 pins that I've used to run this whole MCP. The 2, 3, 4 and 5 then run into the 4 multiplexers, which are these. And the 4 multiplexers each carry 16 inputs. So you can have 16 inputs on one Arduino pin. The reason I've left this one long on a loop is because I've only used 6 pins of the 16. So I've got 10 spare pins there, which I might end up wiring to one of the Hispa controllers or the Hispa panels. So I've left that on a long loop, just for easy access really, to get to it, to wire the Hispa into it. I may put the Hispa on its own multiplexers, I just haven't decided that far ahead yet. Always got to forward think in this game. There's so much forward thinking involved, because if you don't forward think, you can't get to anything. So if you forget to do something, it's a big headache to then try and get to it at a later stage, which I found out during the build of this. I mean, it's not been without its problems. Just today, if you'll remember on the Zebo community page, I was having an issue with displays going out as I was turning the encoders and then randomly going out. And that turned out to be something, just after I posted it, I figured it out before anybody had commented. And the reason they were going out is because I forgot to run a pull down resistor. If you can... I'll try and show you. I don't know if you're going to be able to see it or not. But in there is the... I'll tell you what, I'll get another display and I'll show you. So this is a Max 7219 board. It's exactly the same as what I have fitted in here. And the 4 pins, or the 5 pins I was trying to show you were these 5 here. So the VCC is the 5-volt power. Ground is obviously ground. DIN and CS, they go to pins 27 and 28 on the Arduino. all your displays have to run to pin 27 and 28. And the CLK at the bottom is the one that goes to your Arduino pin. And it's this CLK that you have to run a 1 to 3,000 ohm resistor and just ground the other end of it. So you're running a resistor to ground as well as the cable from CLK to your pin on the Arduino. If you don't do this, this was what was causing my blackouts on my displays. Basically, when you first started the sim, they all lit up fine, and then as you started changing one, sometimes the others would go out, or they'd go out at random times. There was just no telling. And as soon as I put the resistor in, all my problems virtually went away. I still had a slight problem where the displays would work for maybe 5 minutes, and then all of a sudden they'd go out again. This I found to be my power supply. I was running 6 volts because I thought the white displays needed the extra voltage, but this turned out not to be the case. The problem was not the voltage, but the ampage that the power supply was putting out. It was only 1 amp. So what I ended up doing was changing back to 5 volts with a higher ampage output. So I think it's a 3 amp output now, max output that is. So 5 volts, 3 amp, everything works fine, as you saw in the you'll see in the next video. So I'll try and, this Arduino here is my Air Manager Arduino that controls my LEDs behind the buttons. And there is just a quick scan through of everything. Now it's wired. The black plug that you can see on the end is my backlight plug, and the blue and yellow cable that you can see tie wrapped up is what is going to carry the backlighting on to my ethos display. Originally, when I wired up the 5 volt power to my max boards, what I did was brought the power into the first board, and then I jumped it out of the first board onto the second, and jumped it out of the second onto the third. When I was having the issues with the displays going out, I thought that perhaps that style of wiring was the problem. So what I did is I came back and desoldered them and put in this little piece of board and all that is just my power coming in, then makes the whole strip live with 5 volts. And then I've just wired all my max boards onto that strip. It turns out I probably didn't need to do it like this. I could have left it as it was, but it's something I've now learnt for the future. So 1 wire is my 5 volt input, and then the 3 wires go to each of my 3 max displays. Pretty much everything is soldered on the back here. You can see my connections in there. I'm not the greatest solderer in the world, but I'm obviously doing something right. At the end of the day, I'm a carpenter. I'm not into electronics. I've had to really sit down and study this and play with it to get everything worked out. So that sort of leads me on to my next point, really. If you're watching one of my videos, please watch it till the end, because I'm sort of learning as I go. There may be things that I say earlier in the video that turn out not to be right, but I will always come back and correct it later in the video. So you know, a good point of that is where I said about in an earlier video that I needed to use 6 volts because of the white displays, and I've just now told you that actually 5 volts is okay, but I had to up the ampage of the power supply. So I do my best not to give you false information, but all I can say is watch them till the end, because if I do give you false information, I'll always try and correct myself. I'm not afraid to admit mistakes. I don't try and hide anything. If I've done it wrong, I'll tell you I've done it wrong. Because if I don't tell you I've done it wrong, you might try and copy it and find that it's wrong yourself. So me making these videos will be pointless. So that's it really. That's the back of my MCP. I've tried to keep it as tidy as I can. Obviously you can see there is a lot of wiring going on in there. I probably could have kept it a bit more tidy. Cable management is not one of my best qualities. But I don't think it looks too bad. I mean, I've never opened up an Open Cockpits, for instance, one of their MCPs, to see what it looks like inside. It may look like this, I don't know. But I mean, I'm happy with it. At the end of the day, it's not going to be seen. I have seen, I'm not slating anybody, but I have seen other people's wiring on YouTube, etc. I'm not going to name any names, but I would say that some of theirs are a hell of a mess. You know, at least I've tried to keep it all within, you know, the 4 inches ish depth of the MCP. But there you go. Sorry for the dodgy camera work. I'll probably have to get myself a little gimbal or something if these videos carry on. But yeah, thanks for watching, guys. I'll see you in the next segment where we get it all up and running and show you how I interface it with SimVim. I'm not going to be doing a full tutorial on SimVim. If that's something that you want, let me know. I can always do it. But SimVim has got good instructions. It's fairly self-explanatory. So I don't think anybody will have any problems figuring it out. There's no coding involved. It's just simply click the picture, click the button, assign it to a pin, save it, run the sim, done. Okay, see you in the next one. Hello everybody, we've reached that time again. The MCP is now finished. I've got it all rigged up to the sim, as you can see. The first thing that we're going to do is jump over to SimVim. If you've never used SimVim before, it looks a lot more confusing than it is. If you actually sit down and follow the instructions on your breadboard, it's actually very simple to use compared with Air Manager and MobiFlight. I mean, don't get me wrong, Air Manager and MobiFlight are superb, but SimVim is a hell of a lot easier. So with SimVim, to configure your switches, you go to the configurator, which is, it's not a program, it's a website. So you go to simvim.com, you click on configurator. This is where you'd start to program your buttons, and you can see here that there is pre-made pictures. So for instance, transponder, it brings up all the different transponder options. You would then click which one you want, and then you can click which button you want to assign. So there's you know, common nav. There's everything here. Obviously, we're interested in the Boeing 737, so I'll click on that, and it brings up this picture of the Boeing. We're doing the MCP, so we click on that, and then it's just literally a case of clicking on the button that you want to assign. So let's say, for instance, we'd wired a single switch for the auto throttle to pin 2 on the Arduino. All we simply do, so the blue squares are LEDs, you can see auto throttle armed, and the yellow squares are the switches. So if we had our switch, our physical switch wired to pin 2, we'd simply click auto throttle arm, pin 2, and that is it. Your switch will now work the auto throttle on the MCP. The last step to do would be to click save. Okay, and then you would save that into this location. So it's your X-Planes, plugins and SimVim folder. And it's that file there. Obviously I'm not going to save it because I don't want to overwrite mine, but that's where it goes. Each time you close the configurator, so if I go on to something else, and then you go back to configurator, you can see that it's now cleared the page of what I'd set. And to then edit it, you would click on edit, click on your file that's in the SimVim plugins, and open it. Obviously this is going to open my file, but it would open the one that we'd saved. So this is my file, and you can see I've used 5 pins in total for the whole MCP, and there's still a lot of pins that I could have used on the back. So each input multiplexer can have 16 switches. So you can see on pin 2 I've used all 16, on pin 3 I've only used 15 of them. Pin 4, it says I've used 3, but if we look at it, I've actually used 5 for the bank angle, 5 for the bank angle, and then 2 for the heading encoder. So I've used 7 pins in total there. So I could wire something else. I said earlier about wiring the ethos in the back, to make use of all these empty pins. And pin number 5 is my output multiplexer, which is driving my Max 7219, is it? I can't remember now. Yeah, 7219. So my output multiplexer can have up to 16 Max 7219 boards running off of it. And as you saw from the build earlier, we are only using 3. And each of those are controlling 2 displays. So 6 displays on the MCP in total, and 3 max boards. If we go into further detail, you can see that the max board that is connected to pin 0 on my multiplexer is controlling the autopilot speed and the captain's course. So the IAS, indicated airspeed, and captain's course, which these two here. So remember, we have one max board in the middle of them two, and then the display split 2 ways. My second max board is the one in the middle here, and that's controlling the heading and the altitude. And then my third max board is mounted here, and that's controlling the vertical speed and the first officer's course. And it really is just as simple as that. To set up the 7 segments, say if we had a 7 segment on pin 30, for instance, all we would do is go to the picture, and let's say I wanted to do my altitude. It's just a case of clicking the altitude, telling it you want it to be a 7 segment and not an LCD, and then you click whatever pin that your 7 segment is wired to on your Arduino. So in this case we'd say pin 30, Oh, I apologise. We need to tell, the first thing we need to do is tell that pin 30 has got a 7-segment display on it. So it's, if you were using a multiplexer like I have up here, you would click add mux for 7-segment. But if you're just using a single 7-segment display, so a single max driver, you would just click this one. Here is where you tell it what driver you're using, so max 7219 up to 8 digits. You can then set whether you want it mirrored or common anode. And the minimum working voltage, so if the bus voltage on the aircraft drops below, I think it's 8 volts from memory on the 737, if it drops below 8 volts, the displays will blank out. So we would confirm that. That then adds a 7-segment display to pin 30. Now we tell it that we want the altitude on there, so we click that, and then point it to pin 30 and put it in the new entry. The shift position from the right hand side, as if, say for instance, with my speed and my course, that's probably not a very good example actually. Let's say my vertical speed and my course, because on my vertical speed I'm using 5 digits, I've had to jump 1 digit across to this side from the course. So my vertical speed, each side of the max can only run 4 displays. So what I've had to do is wire the 4 from this side and nick 1 pin from this side and jump it across, so that you can tell SimVim to jump your display over if you need to. I probably didn't explain that very well, but I hope you get the gist. And that's it. You click done, and that's the 7-segment now set up for pin 30. So you would launch the sim and you'll see that your 7-segment is displaying the altitude. So now we'll jump across to the sim. I've got the sound muted, just because you don't want to listen to Boeing on idle. But you can see that starting from this side, captain's course, you can see everything is working. Speed, heading, the bank angle is working as well. Oh, that was me jogging the heading at the same time. Altitude is working. Vertical speed. And minus. And first officer's course. Acceleration is into SimVim, so the quicker you turn it, the faster it jumps through the numbers. There's a little hidden feature I found in SimVim as well. If you wire up your encoder and find that when you're turning it right, it's going down in altitude, you simply go up to plugins, go to SimVim cockpit and input options. And now it asks you to turn or rotate your encoder. So you would turn it, it then picks it up that that's the altitude encoder. And from here you tell it what type of encoder you're using, so type 1, 2 and 3, whether you want acceleration, which I've got 3+, and if you want to invert it. So in this case mine was turning the wrong way, so I've inverted the encoder to turn the right way. And you can do that with any of the encoders. So auto throttle arm, as you probably saw earlier in the video, the LEDs because I wired them not correct for SimVim. I've had to run the LEDs through Air Manager, which I will show you now while we are talking about it. So this is Air Manager. You can see I've made my own little script. Took a bit of work from me because I'm not the greatest at scripting, but I managed to write this myself. And if you sim my FMC video, it's exactly the same. You would just go through, tell it you want Arduino Mega and what channel it is, so channel C, because it's my third Arduino that's connected to SimVim. The first one is my Mega 2560 from FMC, the second is my Arduino Uno from FMC, so and this one will be the third one, so it's channel C, and then what pin it's connected to. So I've written all this to be able to bring this up, to be able to do it simply, and it's working absolutely fine. So back to the FMC, the flight director and the master arm light has come on. And a flight director on the first officer side. With Air Manager. Air Manager monitors the status of this light, so irrespective of what position the flight director is in, if the light on the simulator goes out, this one will go out as well. So it's not directly controlled by the switch. You can see that the master arm has now jumped over there. So the next thing I'll do is I'll cut the camera off, and we'll badly get the plane into the air because I'm flying it with a mouse, because this is my test setup computer, and you can see this highly detailed airport that we're at. Yes, it's a patch of grass in the middle of the ocean. That's because I've got no scenery installed at all, and I just wanted it for on this computer just to check that my switches are working as they should, so I don't actually fly on this computer at all. Hence the reason we'll be taking off with the mouse, which is always interesting. But I'll get the thing in the air, we'll get it on stable and on autopilot, and then I can show you the LEDs behind the buttons lighting up. Okay, welcome back. We've got the bird in the air, and you can see I've got it on speed, heading select, and at the moment we're climbing, so I've got it on vertical speed at 1500 feet a minute, and the command A is on. While I think of it, the disengage bar is one I printed from Kyle Clark. It's just a bit too big, so what I want to do is just bring it in at the edges, just to bring it inside these white lines and print it again, so that's why I haven't stuck it on yet. It's just sitting on there, and I'll show you the one that Hispa Panels sent me, and you can see why I wanted to print my own. What I'll do is just put you on the big camera a second. This is the one that Hispa Panels sent. Nice join line in the middle of it. Lovely. And you'll see that it's also a really sloppy fit. The right size, but I didn't like that, so I printed this, which is a nice tight fit. I just need to make it a little bit smaller. What I'll do is I'll leave you on this screen for a second. You can probably see it a little bit bigger. By the looks of the camera, the displays here are sort of being blown out by the camera. It doesn't look like that to me. I wonder if I can try and get a bit of a better view of it. There you go. Still blowing out a little bit. It's just the bright, because they're white LEDs, they're quite bright. Actually, I'll give you a... I know this is really professional filming and all, but give you a close-up view of everything. You can see I've managed to scrape the paint off the edge of that one, so it's just something I need to touch up. Right, back to the MCP, so you can see that the CO or Mac button is working, so it's now changed to 0.40 Mac. I can only do what it will let me do, so we're on speed. VNAV it won't let me do because I haven't set an FMC up, nor LNAV. VOR lock it will let me put on. Approach it will let me put on. Level change, you can see that the level change is lit up, the speed's gone off and we're back to N1. Altitude hold, the out intervention works. We can go to vertical speed and dial that into whatever we want. Command B, CWSA, CWSB, and you can see that the master arm light is jumping between first officers and captain side. And the captain's course, you can see the vertical speed has now gone out because we've reached our altitude of 6,600, and you should see the out hold light come back on. There you go. So everything is working. There's no more. The only small job I've got to do is just to reprint the disengage bar. But apart from that, everything's working. Backlight is all working, and what I'll do is just go cut the lights out. So you can see the camera is still slightly blown out by the white display, but you can see how effective the backlighting is. That's on full brightness at the minute, but obviously I can dim it down to virtually nothing. Give you another quick close-in view of the backlighting. Oops. Obviously we're getting a lot of light bleed around the edges, but by the time it's fitted in the glare shield we won't get that. I may even make a small box to cover the whole thing in. I haven't decided yet. I'll decide on that when it comes to mounting it in the glare shield. But there we go. One MCP complete. Well, if you've made it this far, I congratulate you for sticking with it. It's been a long video, and I thank you very, very much for watching. If you've got any comments, please do write them below and I will answer them. If you've got any tips, something you want to see on my videos, let me know. You know, I'm still new to this, I'm doing the best I can. But if you can give me pointers, if there's something you don't like about my videos, things you do like, just let me know. You know, I can change what I'm doing. I'm kind of doing what I would like to watch if I'm watching somebody else's video, but everyone has different opinions, so you know, I can try and do a little bit to keep everyone happy, or if I'm doing it right, let me know. So on to the next project, which will be getting the ethos put together to go alongside this. It's actually going to be quite a simple project compared with the two that I've already done. The FMC and the MCP, I think I've started with probably the two hardest things, and the two with the most wiring, obviously, apart from the overhead. So it should really be a walk in the park compared to what I've already done. So that wraps up the MCP video. Thank you all for watching again, and I shall see you soon.